3,300, that shows up 3,374 RPM. Now what we're going to do is change it back to 12 volts and see if we can reach the motor's full potential of 3,000 RPM using 12 volts and far less input power regarding watts. Okay? It simply slips on. Slides over the case. Notice I've got some marks in the case here. Got some marks on the case here. I don't know if you can see that very well. This is 4, this is A, this is 3. It's in correlation to what we're going to add inside these slots. The casing of this DC motor is about 1/8 of an inch thick. So what we need, if we just put a magnet on there, the casing wants to deflect the magnetic strength, the flux, outward. And we don't want that. We want it to go inward, into the case. So what we do is we come in with a 1/4 of an inch backer, which is heavier than the 1/8 inch, and forces it to reflect inside to those north and south pole magnets on the stator. Now in the retainer, I put 2 Neos and 1/4 inch bar steel in each of the large positions, and just one of the small ones in each of the little narrow slot positions. Let's see what it does. Check the RPM, 3720, 26, 3730. So it's gaining 3,730 at least. Power. The draw is 12.21 volts and 1 amp. On the motor with the Stardate retainer, we've got 2 of the bar magnets in each of the 4 positions, and we've got 8 of the little narrow ones in each of their 4 positions. Let's turn it on. See what the RPM is. Roughly 3,500 RPM. Goes up and down a little bit. It's drawing 12.3534 volts at 1 amp. Now at this point, you would think that if you just added 2 more of these Neo bar magnets to each of the 4 locations for them and filled the stator retainer up, 8 in the position of the small ones, and all the way around, and 4 in those positions,